Every time you flip a switch, electricity appears instantly. Lights turn on. Your television starts working. Your phone begins charging. But have you ever wondered where that power actually comes from? Electricity travels an incredible journey, often hundreds of miles, before reaching your home. It all begins at power plants, where different energy sources are converted into electrical energy. In many parts of the United States, natural gas power plants generate a large portion of the electricity we use every day. Other power plants use flowing water, nuclear energy, wind, or sunlight to produce electricity. Hydroelectric dams use rushing water to spin massive turbines connected to generators. Wind farms capture the energy of moving air and convert it into electrical power. Solar farms transform sunlight directly into electricity using photovoltaic panels. Regardless of the energy source, the goal is the same: generating electricity efficiently and reliably. Inside a power plant, large generators spin at high speed. As these generators rotate, they create electrical energy using the principles of electromagnetism. Once electricity is generated, its journey through the power grid begins. But before electricity can travel long distances, its voltage must be increased. This happens inside a substation located near the power plant. Large transformers step up the voltage from thousands of volts to hundreds of thousands of volts. Why use such high voltages? Because transmitting electricity at high voltage reduces energy losses and allows power to travel efficiently over long distances. The electricity then enters the transmission network. These are the giant power lines and transmission towers you see crossing mountains, deserts, plains, and cities. Together, they form part of the electrical grid, one of the largest and most complex machines ever built. The grid connects power plants across the country and delivers electricity to millions of homes and businesses. Behind the scenes, grid operators continuously monitor electricity production and consumption. They must ensure that supply always matches demand. If millions of people suddenly turn on air conditioners during a hot summer day, power generation must increase immediately. When electricity reaches a city or town, it enters a regional substation. Here, transformers reduce the voltage to levels suitable for local distribution. The electricity is then sent through distribution lines that run along streets and through neighborhoods. These lines carry electricity closer and closer to homes, schools, offices, and businesses. You have probably seen neighborhood transformers mounted on utility poles or installed in green boxes near homes. These transformers perform another important task. They reduce the voltage even further to a level that can be safely used by household appliances. From the transformer, electricity travels through a service line connected directly to your home. Before entering the house, the electricity passes through an electric meter. The meter records how much electricity your household consumes. This information is used by the utility company to calculate your electricity bill. After passing through the meter, electricity enters your home's electrical panel. The electrical panel contains circuit breakers that protect your home from overloads and electrical faults. The panel distributes electricity through separate circuits throughout the house. These circuits power lights, outlets, televisions, computers, refrigerators, air conditioners, and countless other devices. The moment you flip a switch, electricity is already available, waiting to be used. What feels instant is actually the result of an enormous infrastructure network working around the clock. The next time you turn on a light or charge your phone, remember the remarkable journey that electricity has taken to reach you. From power plants to transmission lines, from substations to neighborhood transformers, and finally into your home. This invisible journey happens every second of every day, powering the modern world around us. Subscribe to Inside Everything and explore the engineering behind our modern world.